All right, so in this video, we want to solve these exponential equations over here, and we want to solve them without a calculator. So when you're solving exponential equations without a calculator, you want to make the bases the same. So you want to think about, in this case, for example, I know that 625 most probably can be converted to 5 to the power of something. So I want to kind of figure that out. I want to turn 625 into 5 to the power of some number. Now I know 5 squared is 25. 25 times 5 is 125, so 5 cubed is 125, and 125 times 5 is 625. So I know 5 to the power of 4 is going to be 625. And once the bases are the same, you can cancel them off and you can just make the exponents equal to each other. So x equals to 4 in this case is my final solution. Take a look at the second example over here. My common base between these two numbers is 2. So I'm going to switch this to 2 squared because 2 squared is 4. And then I'm going to write the exponent inside a bracket because this squared is going to be multiplying with whatever's in the exponent. This side just remains the same. I can cancel off my bases now that the same. So I have 2 times 2x is just 4x. And 5 minus x, I'm just going to write that the same. And now I just have to solve this for x. So I'm going to move the negative x to this side and add it. 5x equals to 5. Divide both sides by 5. And I just get x equals 1. This one. This third example over here, it looks like your common base might be 9. But 9 to the power of 2 is 81. The common base is actually 3 over here. And we're going to have to change the base on both sides. I know that 3 squared is 9. I'm going to write this in a bracket, this is multiplying, and 3 cubed is 27. Now I can cancel off my bases. And now I'll just multiply my constants into my brackets. So 2x plus 2 equals 6x minus 9. To combine like terms, so I'm going to move the 2x and subtract it on this side. So this is going to become 4x, 6x minus 2x, and I'll move the negative 9 to this side. 2 plus 9 is going to be 11. Finally, I'm going to divide by 4 on both sides. So my final answer is just 11 over 4 equals x. All right, let's take a look at the next 3 examples. Slightly more difficult, but pretty much the same. You just have to do the same procedure. So if I compare 8 and 16, I know that my common base is 2, but I have a cube root in this equation as well. So let me convert this to 2 cube is 8, and 2 to the power of 4 is 16. Next, I'll get rid of this cube root and I'll turn it into an exponent. Remember, whatever's outside your root is the denominator of the exponent. So this is just going to turn into 4 divided by 3. So now I can solve 3x minus 3 equals to 4 over 3. I'm going to add the 3 on this side. So 4 over 3 plus 3. That might be a bit difficult to do mentally. So what you want to do is just make a common denominator, multiply 3 on the bottom over here and 3 on the top. 3x equals 4 over 3 plus 9 over 3. So 3x equals 13 over 3. And you want to just cross multiply this 3 to the denominator of the other side, basically dividing. It's going to become 13 over 9, and that can not be simplified. So that is my final solution for this one. Next one over here, this one's a pretty easy one, but we have a fraction now. So remember, we can get rid of the fraction by just moving that to the top and making the exponent negative. So in this case, it's just going to turn into -1. You can cancel my bases. So 3x equals -1 divided by 3, both sides. Final answer is x equals -1/3. And last question over here, best common base to use between these two is 4. You could use 2 as well, but 2 would be a bit harder. So I'm just going to stick with using a base of 4 because that works. I'll first convert the 16 to 4 squared, and then I'll move this to the top. So it's going to become -2. Then I cancel my bases. So 2x equals -2. And then I'm going to divide both sides by 2. So final solution is just x equals -1.